Mhm. All right. So today we will be talking about reusable space launch systems. I represent the company Balkan Space Engineering in Varna, in Bulgaria, obviously. And we have a team of engineers from a number of countries, from Bulgaria, from Russia, from Kazakhstan, from United Emirates. And we are currently developing a project which is called Aspire. It is here. But before I come to that, I have something to tell you about what is the typical, or in general terms, what is the space transportation system? Basically, space transportation system includes 4 segments: the ground segment, the rocket segment, the space segment, and sometimes marine segment as well, like in Sea Launch Project, international project with United States, Russia, Norway, Ukraine, which is not currently in operational status, but still it was a great achievement. And today we will concentrate on the rocket segment, which basically is the launch vehicle and the payload. The payload could be a satellite, or could be a spaceship, manned spaceship, or just a satellite, communication satellite, cargo ship, whatever. Now, in this slide, you can see the evolution of the reusable space launch systems. Here you have space shuttle developed by the United States. Then similar project was developed in the former Soviet Union, which is Buran. And then currently what is probably taking more and more attention is the launch vehicles developed by SpaceX, the American company led by Elon Musk. There are other projects, of course, you can see on this picture. But just to remind you that the critical element, or the most interesting element of the reusable space system, or the launch vehicle rather, is that the reuse of the components of the launch vehicle or the system could be different. Like in a space shuttle program, it is basically a payload for the launch vehicle, and the same in Buran. But in other projects like Falcon 9, for instance, the reusable is the first stage, the booster stage. And what is interesting about it, forms a soft landing on the specific spot or landing zone. But to go back to history, soft landing is not anything new. For instance, back in 1966, a lunar mission launched by the Soviet Union, the former Soviet Union, it was a project of spaceship Luna 9, which landed on the moon softly, took samples of the soil, and brought it back to our planet. So first time in history, we have pieces, small parts of soil from the celestial body, which is Moon, our satellite. There are more missions, but then it was a manned mission back in 1969, which is the Apollo 11 mission, bringing astronauts to the moon. Also soft landing on the moon, and then flight back to home. So the typical return mission for the first stage, which is the most interesting in our case, and which is what Falcon 9 is doing in other projects which are being developed currently, is the difference from these previous missions which I mentioned, like Luna, like Apollo, and the difference being that they landed on not a specific spot. I mean, there was not precise landing in a specific point. Maybe it was like a square of 100 by 100 kilometers. But bringing back the first stage, what is critical is that this stage lands in very specific point, exactly where it needed. So that's a critical difference from other missions, the previous projects. Now, here you see the typical space transportation system flight configuration. But there is a critical difference between expendable and reusable space systems. Because reusable system assumes that after returning to the launch point or to the specific location where you wanted to land, then you need to refurbish it, maybe repair in some cases, and use it again. Sometimes it up to 10 times you use the same stage of the launch vehicle, the booster stage, and then you have to land it somewhere. And talking about where to land, we have different schemes. Like, for instance, in this slide, you have launch vehicles which land in specific areas. They can be saved by using parachute, or you can return to the same point, or you can use aerodynamic. Now, for instance, sorry. Now our company is developing the space launch vehicle with reusable first stage, which is called Aspire. And as I mentioned, we have a team of engineers and aerospace specialists from different countries. And this space launch vehicle will use the first stage, which is fully reusable. And its total weight or lift-off weight is about 400 tons. And payload delivered to the low Earth orbit will be around 12 tons. So we are using different approaches to how to use this launch vehicle, how to launch it and where to land. Our basic assumption is that the production or design, first of all, the design will be done in Bulgaria and in some other countries, but the launch point or the launch system will be Baikonur, Kazakhstan, because Baikonur has existing infrastructure which can be used by us, and certain areas of Baikonur Cosmodrome or spaceport now are returning back to Kazakhstan. Before it was fully rented by the Soviet Union and later Russia, but now Kazakhstan is taking back some of the launch point, so-called launch complexes and other infrastructure. And then we will be using this existing infrastructure, which will significantly reduce the cost of launching of this reusable system. The landing of the first stage, which will be used again, will not be in the same point, at the launch point, but down the trajectory, where typically the first stage drops if it is expendable launch vehicle. So it's about maybe 700 kilometers from Baikonur. And one of the missions we will be performing is the launch to International Space Station, because in parallel with the development of the launch vehicle, we will be developing a spaceship. And the spaceship will also be reusable. In other steps, we might be also using the fairing, the payload fairing, which covers the payload. If we launch not a spaceship, but a group of satellites or one big satellite, then after separation of second stage and the first stage, typically the fairing, the halves of the fairing fall down the road, so to speak, and they are not usable again. But in our case, we are considering the possibility to use the fairing, which covers the payload again. So after the first stage returns to Earth and lands safely, hopefully, we will have legs on the first stage. So it's quite similar to what the Falcon 9 is doing. And then this landed first stage will be returned to Baikonur, where it will be checked, refurbished, in some cases maybe repaired if needed, hopefully not. Sometimes, like Falcon 9 is doing, some of the engines they are using on the first stage, they replace. So it's not 100% reusable in this case, but the stage, the structure, the fuel tanks, the overall structure is used again. And we hope that we will be doing the same. In our case, it's not 9 engines like in Falcon 9, but 5 engines on the first stage and 1 engine on the second stage. So when the return mission is being performed, then at the start, of course, all 5 engines will ignite. Then after the first stage completed its mission, burn out, and the separation of the first and second stage takes place. Then the first stage continues to fly in the same trajectory. And before the landing, when it enters the atmosphere, then there'll be ignitions again to sort of pull over. And then one of the 5 engines in the final phase will ignite and bring the first stage to the launch position safely. So that's the plan. But talking about difference between expendable launch vehicles and reusable launch vehicles, you can see in this slide that for the typical mission of launching 5 tons or 5,000 kilos into 350 kilometers circular orbit, you have launch mass for the expendable launch vehicle, and this data is taken from the existing systems, of course. So it's like 250 tons. But if you use a reusable first stage, you will need to have additional fuel to spend when you do a landing. And you can see the difference, the mass increase is about 35%. If you want to reuse the second stage, then it is 250%. And upper stage, like Space Shuttle, for instance, or Buran, or other projects, then it's almost 300%. Fully reusable is 10,000%. So it's a difficult task and very expensive and requires a lot of effort. In this table, you can see what is the most expensive part of the launch, typical launch vehicle, which makes, gives the reason why you want to have a reusable first stage. You can see the structure of the first stage is about 15% of the total, and the first stage engine is about 25%. Of course, it's average. It's not like a concrete space launch system, but it's on average. So in total, it's about 40% of the total cost. Or that makes a good reason to have the launch vehicle reusable. That's why, Falcon and some other companies are developing the reusable launch systems, and we are following suit. Of course, as I mentioned, there could be different ways of saving, so to speak, the first stage. Like, for instance, as I mentioned, and we will be doing exactly that, we will land in a specific point and then return to base, and where the refurbishment and repair will be done. Then there is what Falcon is doing is basically landing in the target area near the launch point. Here we have parachute saving, and this one is just, like winged. At this slide, you can see that it's a very difficult task to save the first stage of the launch vehicle. It's, entering the atmosphere with high speed, about 3 kilometers per second, and the heat is so high, and the dynamic pressure is very high, so its structural integrity must be ensured, and heat protection must be also ensured. And then you have to ignite the engine to bring it to the landing point. And to do that, you cannot just, ignite it at any place. There is a specific point at specific height and specific velocity where you can just ignite the engine, which will pull over and bring it to the landing point. And that's not an easy task. It requires a great deal of analysis, calculation, trajectory simulation, etc. So here on this slide, you can see basically the requirements or conditions for bringing to success. What this table shows is what is required additionally compared to the expendable launch vehicle. Expendable launch vehicle is like, shoot and forget. But when you use it again, you need additional fuel, you need flight control, you need sometimes aerodynamic surfaces, which will, control the landing trajectory, because it cannot be chaotic. You need specific orientation of the launch or the stage. Basically, it's a cylinder, heading backwards, so to speak, because it goes down with the engines, with nozzles facing forward, and that's not an easy, from the aerodynamic point of view, it's not an easy task. That's why Falcon 9 and other launch vehicles, in our case as well, will be using so-called grid stabilizer to ensure orientation of the launch vehicle during the descent and in the final point, so it goes down strictly vertically before the ignition of the engine, which pulls it back.
Dr. Arzumanyan, if possible,
Yeah.
can you wrap up a little bit because we are running behind schedule a little bit. So if you can,
Okay. All right.
more important thing, and we can discuss later.
Sure. All right. So probably I should, wrap it up and thank everybody for joining this meeting today. And should you have questions, please send to our company. I think the email address is available. So then I end my presentation today. Thank you very much.